Okay, now we are going to handle number 13 up to 16. So these are the numbers. You see 13, 14, then we shall also come to 16, and then 15 as our last numbers. There, we have finished number 9. We have finished section A. Also number 9 and number 12. Then we handle it the last part, 13 up to 16. So this one was from trigonometry, specifically the use of our formula. So it says express this in the form of this, where r and alpha are constants. Hence, find the maximum value of this and the smallest positive value of theta at which the maximum occurs. So what we do, to use our formula, of course, even if we don't set for you this, you can handle this yourself. If you study a certain sign, it's always put it in terms of sign. We have seen our formula in details. The videos are there in trig, in the playlists. You can visit there and then you go through trig. Down there you will find the use of our formula and the formula also there right away. So our part is, we had to say let r, this one which was given in the question. So if the question dictates, then you have to use that d 8 sine theta minus 15 cos theta. So here we need to get the value of r. So it's our r, so this is going to be our a, this is going to be our b. So our r is always given by the square root of a squared plus b squared. This is my a, this is my b. So I'll say this is going to be the square root of a, which is 8 squared, then plus b. B here is the coefficient of this, which is negative 15 squared. And so this one is going to be 64 plus, I think 17. Yeah, 17. So my r is 17. How do I get alpha? Our alpha is equal to tan inverse of. Always get used that we are using here sine, so its coefficient now becomes a denominator. So you get now 15 over 8. Now ignore that like that. So here now my alpha becomes 15 divided by 8, which is 61.93 degrees. So therefore, my 8 sin theta minus 15 cos theta is going to be equal to, now you can every see. So this is the positive, so you can every see our r, we have our r, which is now 17, then sine of theta, then minus alpha, which is 61.93, that. So now you see, we have expressed this in terms of that. So all of this is equal to that with ease. Now, they are telling us, hence find the maximum. So this was our part A here. So the next part is, let us see here, the next part. So that the maximum of sine, the max of sine theta is equal to 1. But now, for now, the whole of this now, 17 sine theta minus 61.93 degrees, comma. For the sine, then the sine of the whole of this is going to be 1. So, if now sine theta minus 61.93 is equal to 1, then the maximum value is going to be now 17 into, where the whole of this is 1. It is going to be 17. Occurs now, we just now solve this. Remember, our sine theta is equal to 1. have 8. The angle it occurs, we solve for this angle here. So you see that here we have theta minus 61.93 degrees. Sine inverse of 1, we have 90 degrees, we have 450, depending on the revolution. But here they told us to get the smallest positive. So that's why I'm concentrating on only 90. So here my theta will be equal to 90 plus 61.93. And so there my theta is going to be 151.93 degrees. So that's the smallest value where. So the maximum value is 17 and is occurring at 51.93 degrees. So that's how you can get all the problems with ease. So the idea is if they ask for the minimum, then sine of theta, its minimum is occurring when the all of this is equal to 1. Remember when we are drawing the sine curves, sine can never go beyond 1. Sine of theta can never, its maximum is there, then its minimum is at -1. So that's it. I wish you well. We are going to see now number 14. Okay, so now here comes number 14. Number 14, first of all, it had equations where we have to solve simultaneous equations. Then also have it. We have the idea of roots quadratic equations. So we handle part A. So part A, we had to solve these two simultaneous equations. So all we had is to make one result and then put into the other. So from there, you can see from here, my x is going to be 6 minus y. So I call this equation 1. So if I put it here now, put 1 in this. So you have 2 into where there is x. We put now that. Then plus 5 into equaling 0. Then we expand it. So this is going to be 2 into, this is going to be 36. Then plus, this is, okay, this is going to be 30 times 1, 31 minus 5y squared plus 2y squared equaling 0. So can you correct like terms? Okay. So you see here, this is going to be 72. So I have 72. Then this is going to be 24. So this is 24. This 24 plus this. Now I have negative 24 plus 30. I have now plus 6y. Then I have 2y. 2y minus 5. First of all, this one is going to give us negative 3. This one we have negative y squared equaling to 0. So that's how we solve that one. Simple as that. So from here, to simplify this, the remaining idea is just take everything that sides. So y squared minus 6y minus 72 is equaling 0. Two numbers I multiply, I get 72 negative, but when I add, I get 6 negative 6. So there you can count 72. You can see in 72, 72 has 1, it has 36. Okay, 1 and 72, 36 and 2. Then we have, and divide this by 3. Okay. So we have also another one is going to be divided by 3, which you see we have 24 and 3, and so on. So solving that, the idea is very easy. So the other is 12 and 6. 12 over 6. So when I multiply these ones, I get 72. Now, if the sum is negative, it means that the big one is the one which is negative. Then, if this you start to see is negative, so meaning these two have different signs. So from there, I have this as y minus 12 into y plus 6 equals 0. So either my y is 12 or y is negative 6. So then from 1, that our x is going to be, when I put here 6 minus now 12, I get negative 6, or my y is going to be 6 minus my x 12. So those are the two values for this. Because you see, this one is it was quadratic in terms of x, and then it was quadratic in terms of y. So we had two values of x, then two values of y, and so that's how we had to handle that with ease. Anyway, when I come to number part B, so part B, we add x squared minus bx plus q equaling 0. So if we compare with the general, x squared plus bx plus c equaling 0, you can start from here. My a is 1, my b is negative b, and then my c is q. Then now the roots were alpha and beta. So meaning, if I get a sum, alpha plus beta, the sum of the roots, remember it's given by negative b over a. So my alpha plus beta is going to be b. Then alpha beta, the product of roots is c over a. So my alpha beta is going to be q, because a is 1. Now, the one has to get the equation whose roots are these. So we need now to get the new product, then the new sum. So from here I come and say the new sum is going to be, now we add those two. So there it is, just cross multiply, and then we simplify. So you can able see when you cross multiply here, we have alpha squared beta minus beta plus alpha beta squared, then minus alpha, we roll over alpha beta. So this one is going to give us, now you see if I bring this close, I'll be adding alpha squared beta plus alpha beta squared, then minus alpha plus beta, all over alpha beta. I have alpha beta and I have this now. Here I'm seeing that alpha beta is common. If I factorize it out, I'll be having this now as alpha beta into, I remove alpha beta here, I made it alpha plus beta minus alpha plus beta, now over alpha beta. So from this step, you can come to that step. It's okay. So now if you substitute, you see that our alpha beta is q into alpha plus beta is b, then minus alpha beta, alpha plus beta, then the whole over q. So that is our sum, but the new sum. So the new sum, then the new product is going to be, now we multiply these two, then times, so that's what happens to multiply. This times this, we get alpha beta, the whole squared. Then this times this, we get negative into alpha squared plus beta squared, because this is going to also multiply this. Then this times this, we get a 1, the whole over alpha beta. These two multiply each other. Now, from here, you can see this is going to be alpha beta squared, then minus in brackets. We have seen how we use symmetric equations, symmetric expressions to get this. This is now going to be alpha plus beta squared minus 2 alpha beta, then plus a 1, the whole over alpha beta. So substituting in there, we shall be having this as our alpha beta is q squared, then minus, remember when I open brackets, now this one is going to be b squared there, then this is going to be plus 2q, then plus 1, the whole over q. Then the equation equation is given by x squared minus the sum into x plus the product equal to 0. So now my equation x squared minus, now my sum is qp minus p over q into x, then plus the product. Our product is here, it is q squared plus 2q plus 1 down over q equaling 0. So now these roots are forming this equation here. As simple as that. So that's what you had to do on that number if you are a student. Then, so this is it. Some people go on to simplify this by multiplying through by addition, but it's okay when if you leave it there. That's how we had handle number 14. Let us say number 15. Okay, this was number 15. Number 15 was application of differentiation, probably. And then using some ideas of similarity at O level, of course. From O level, those topics of similarity and then learning. Anyway, the diagram here shows the cone of radius A and height h. This is the cone, radius A, height h, in which the cylinder of radius x is inscribed. This is the cylinder that was inscribed in that cone. Express h prime in terms of x and h, so that the height of the cylinder is h prime there. So the idea is we had to use the idea of similarity. And what we had to do, if now I divide this into two equal parts, then I'm talking about, remember, this one is having a flat base. So if I cut into the line, or if I get a transfer section, and then I divide that transfer section into two equal parts. So this is what I'll be ending up with. This is the idea shall be having there. So this is going to be the formula. Remember, we have a cylinder, our cylinder is somewhere here. So that is our cylinder. Now, the height of this cone from there up here is going to be h. So that's the height of the cylinder. I mean the height of the cone from here up to here. Now, from here up to here is the radius, which is a. So here we have a. And then, remember this one from the middle up to this side, we have our x like that. Now, from here up to where the level of the cylinder is h prime. So this one from here up to here is h prime up to here. Then it means that now using slide, it means that we use two similar shapes. So you see this triangle is similar to this triangle, the big one. So it means that I need to get the height of this. But because this one, this is h, and this is h prime, it means that now from here up here it's going to be h minus h prime, like that. So now, using similarity, from here, using similarity, you can able see, and now I will say, or you can say there are many ways. You can say the big radius, I mean the big base over the small base equaling to the big height over the small height. It's up to you. Or I want to, so let us use, so that we don't confuse or we don't do a lot of steps. From here, let us say, from here I'm going to say the small base of this rectangle over the big base is going to be equal to the small height of this rectangle, h minus h1, over the big height of this rectangle, which is h. So allow me to cross multiply. I'll be having xh over f equaling to h minus h1. Now the one that's to express h1 in terms of xa and h. So when I take this beside and bring this beside, that my h prime is going to be now h minus xh over a. So this was our part A. As simple as that. Then part B. we are talking about so that the greatest volume is that. Now to get the volume, first of all, our volume of the cone, that our volume of the cone is given by a third pi r squared. So it's a third pi r, but the radius of the cone is h, but squared, then h, the height of the cone. Then we come to the volume of the cylinder. Volume of the cylinder. Our volume of the cylinder, that is given by VL. Let me call the volume of the cylinder is going to be given by pi r squared h. So my pi, the radius, our radius C is x squared into the height now it's prime. Now so here my volume of the cylinder is going to be pi x squared, but my h time is here. H minus xh, the whole over h. So allow me to open brackets there. So my VL is going to be pi x squared h, then minus pi x cubed h, the whole over a. So open brackets, this x and this x, that's when you have the x cubed. So now, because I need the greatest, then I need to differentiate respect to x. I need to differentiate this volume respect to x. So now from here, my dl dx is going to be, this will be 2 pi x h, then minus, when you differentiate this now, this and this are going to be constants. Like a pi h or a constants. When I differentiate this, I get 3 pi h x squared, the whole over a. Now that from greatest volume or greatest volume, know that our dvl, the x is equal to 0. Imply that now 2 pi x h and 3 pi h x squared, now all over n is equal to 0. What is common is that pi hx is common. So pi hx is common. Here I made it 2, then I made it 3 x equal to 0. So either pi xh is 0 or 2 minus 3 over x is 0. But now, if you want to get the maximum volume of the cylinder, it means that now, first of all, the height of the cone can't be 0. And also, the radius of the cylinder can't be 0 if you are doing square bit. So meaning, and like pi is a constant which we know. So this one can't be 0. So this is the one which is 0. So meaning, our 2 will be equal to 3 over x, and our x will be 2a over 3. So this is the value of x. Now here we have to test if it's the value using the second derivative test. So now from here, using second derivative test, so it's that now I'm going to refer this the second time. So this squared dl, the x squared is going to be 2 pi h minus 6 pi hx over a. So when I substitute x equal to 2a over 3, now my dl dx squared is going to be, some will be having negative. When I substitute x, I'll be having the a will cancel, I'll be having 4 pi h. So 2 pi h minus 4 pi h, I get negative 2 pi h, which is less than 0. Hence this is going to give us the maximum volume. But remember, from here, my volume of the cylinder we are talking about was given by pi x squared h minus This now means that when I put in the maximum, this is going to be the maximum. Now this one becomes B line. Now my B line is going to be now pi into 2a over 3 squared into h minus x, which is 2a over 3 times h over a, this a here. So here, B line is going to be 4a squared pi over 9, this one, into h minus, this one cancels, so 2h over 3. So my B line here is going to be 4a squared over 9 pi, the whole of this one is simplify, you get h over 3. So now, you see, in my equation I have 4 pi. I mean 4 over 9. So 4 over 9 into pi over 3 is squared h. So mine is here. But now, the whole of this, you can every see. The whole of this is b, which is there. So this is 4 over 9b. And so that one becomes our proof. So that's what I will add. And number 15 really easy. It was taking 12 marks. So that was the idea I had to use. That's it. Now let us see our last question, number 16. Okay, the last number was that one all coming from differential equation. So the differential equation, that was the number. And then this was, I think, one of the the simplest in that paper. Just to, anyway, this was the number, so you had to solve that differential equation. They are giving you conditions here. So what you have to do is to first separate here, calls for separation of variables. So you separate variables, so this one goes here, you have root s, the s equaling to 2e exponent dt. You put now where s one side and then it is one side. So we covered differential as a topic, it's there, and list it and see the details. Now, you see this one is the same as a half. And you can do it at once or anyway, for the purpose of seeing, this is a half, the s equaling to 2e power t dt. Then after that, we integrate these two. The s equaling to integral, this is a constant, 2e to t dt. So you have to remember how to integrate. You increase the power by 1 divided by the new power. So this will be now s 3 over 2. When you add 1 here, the whole over, the new power is 3 over 2 equaling to 2 into, how to integrate exponentials. The first division is to get 2, then the reciprocal, so you have 1 over 2, and exponent to t. Then plus a constant of integration. So now simplify, this becomes 2 over 3 exponent, this is s. But you could finish that in one step from here and now come to the step of s, 3 over 2 equaling 2. So that one cancels, e to power t, and plus and c. Then they are giving you conditions. So they're telling us that when s is equal to 9, t is equal to 0. So can you put, when you put them here, you have 2 over 3 into 9 power 3 over 2 equaling 2 e 2 into 0, then plus c. We are doing this, they are giving us initial conditions so that we can get a constant of integration. Anyway, square root of 9 is 3 power. So here we have 3 power 3, or you can stop, we have 3 power 3, which is 27 divided by 3, that will be 9 times 2, that will be 18. So we have here 18 equaling to 18 equaling to 18 equaling to 1 plus 6. Is that our 6 or 17? So now dividing it back. So 2 over 3 is 3 over 2. equaling to e to t, then plus 17. So this was part A. Then part B, amendment 1, I want us to get t is unknown when x is 16. Let's come and punch it there. So here it shall be having, so we have 2 over 3, then 16, 3 over 2 equaling to e to t plus 17. So the rest, so you have e to power t equaling to. When I simplify this, the whole of it I have to divide in. Sorry, I have to divide by that. Then 16, 64 times 2, 3. So here we have 1, 2, 8 over 3, then minus 17. So if you get natural log both sides, you see natural log here. So our t will be half into natural log of 128 over 3 minus 17. So here our t is going to be now this one is giving me 1.6 to 6. I want to see significant figures. So my t is 1.6 to significant figures. Significant figures just count 1, 2. This is another 0. Then B, Roman numeral 2. They want S when t, so they want S when t is 2.4. So just substitute here. So our 2 over 3 is 3 over 2 is going to be e 2 into 2.4 then plus 17. So it's that our s 3 over 2 is going to be 3 over 2 cross multiply divided of e. Oh, this is 4.8 plus 17. Then we can get this. Then here you have e 4.8